Welcome back to the Math Class Podcast series by Statistics Bio 7. This is episode 4, and today we are exploring a critical part of the data analysis, outlier detections. Outliers biomedical data sets. An outlier is a data point that differs significantly from other observations in a dataset. In biomedical research, outlier can be much higher or lower than the typically value and may result from data entire error, fault measurement instruments, or true biological variability. For example, if the average hemoglobin level in a sample are around 13 to 15 milligram per deciliter and one patient has a value of 19.5 milligram per deciliter, that point is considered an outlier. Outliers are important because they can shake statistical results, especially the mean and standard deviations. They may also misleading hypothesis test such as t-test or ANOVA by violating the assumptions of normality and homogeneity of variations. In clinical research, handling outlier properly ensure valid conclusions and properties the integrity of the study. In practice, a researcher must carefully evaluate whether an outlier is a true biological observation or an error. If the value is genuine, such as a rare case of extreme hormone level, it must be included and discussed separately. If it's clearly due to the data entire mistakes or abnormal lab conditions, it should be excluded or correlated. MedCalc softwares provide statistical tools like Grubbs Test or boxplot based detections to identify such value and support information discussions. So open the MedCalc software, click to the file menu and click to the open options and select to the Excel file, the data already entered. So now the analyst for the biomedical data set. So this is for the ID and this is for the categorical variable and numerical variable for the hemoglobin and glucose level. So now analyzed for the outlier. So go to the statistics menu and select for the second one in the outlier detections. So open the new tab for the outlier detections. So the first one for the variable options. Choose the numeric variable you want to analyze for the outlier. For example, the two numerical value for the hemoglobin and glucose. So choose for the hemoglobin. So the next one for the filter option, it is optional only. Use this is a we want to analyze the subgroups because we take the two groups, group treatment A and treatment B. So if you want the subgroup analysis selected for the treatment A or B, because enter to the group is equal to double opposite the treatment A. Okay, this is for the subgroup selections for the treatment A only. So click to the OK button. You want analyze to only for the hemoglobin subgroup for the treatment A. So only for the now analyzed for the subgroup for the filter the hemoglobin A, the only sample for the 7 samples. So the treatment A. Or if you common enter the whole the samples for the numerical, don't the options not mentions. So next one for the method of the outlier detections in the right side. So the first one for the Grubbs left side. So the usage of the biomedical data To detect low outliers, because our data is low blood pressure, selected to the Grubbs left side. The low extreme value only the selected in the Grubbs left side and the Grubbs right side. To detect how high outlier, because of high glucose levels. If we use suspected only the high level extreme only, and the next one for the Grubbs double side. So detect the both higher and lower extremes value. The recommendation for the usages best for the general biomedical data. And the fourth one for the generalized EDS test. So use only the more than one outlier may be exit. The recommended if the numerical value for higher than 25 or multiple outlier detections, because our the data only one outliers. So how to identify this outlier? The very simple data. So generally identified for the hemoglobin level the 19.5. So our suitable the data for the hemoglobin outlier both minimum and higher extremes the hemoglobin level. So selected for the double side. And the Tukey, the based on the IQR boxplot method, the good for the visual review, not for the test based. So additionally for the options, then alpha level, the default for the 0.05 for the Grubbs and EDS test only. If you selected for the generalized EDS test, then your numerical outlier value the higher than 25 selected for the 25, and the alpha level, the keep this unless you have the clinical reasons to be the strict, the change to the alpha level, change to the 0.01, unless the standard the alpha level 0.05, this is a common. So our data set not suitable for the generalized EDS, so the checkbox unclick, the only selected for the Grubbs and Tukey. Then optional additional one, the logarithmic transformations. So the only if your data is saked, they selected for the logarithmic transformation, because the example for the data, the hormone levels are CPR data set. So another one for the test for the normal distributions. So the totally the 5 options, the already discussed for the before the video, and continue the simple discussions for the Shapiro-Wilk test. Best for the all around the test for the small to medium biomedical data set. The mostly recommended for the all the biomedical test for the Shapiro-Wilk, and the next one for the Shapiro-France test. The faster than Shapiro-Wilk, good for the larger samples, because use your data set for the numerical the 50 above, the used for the Shapiro-France test. And the Pearson's test, the detected for the sickness and Crustius test, use when cornered about the data safe. And another one for the Kulmarov-Simirov test, the less powerful, not ideal for the small samples, avoid for the medical data set. And the last one for the none. The no normality check, the not recommended for the clinical research the data set. So the generalized selected for the Shapiro-Wilk test. So now click to the OK button, analyzed for the outlier detection, the hemoglobin, the medical data set, biomedical data set. So click to the OK. So analyzed for the variables biochemical, the total of the samples for the 14, and the lowest value 13.20 and highest value hemoglobin level 19.50. The arithmetic mean for the 14.0, then median value 13.60, standard deviation 1.59, and confidence of thickness 3.64, the p less than 0.001, and confidence of cruelties, the test value 13.47, the same p value for less than 0.001. The Shapiro-Wilk test for the normal distributions, the rejected normality, the w is equal to 0.41, p less than 0.001. The suspected outliers. So the dataset subsetted outliers, the Grubbs double side, the alpha 0.505 level, then 19.5, the subsetted outlier, the value hemoglobin the higher, then Tukey's value, the outside value none, the fair out value 19.5. So if you want the data set for the box and whisker plot, click to the options, then open the new tab for the box and whisker plot. The plot options for the all the data, our data is non shaked, so unshake for the logarithmic transformations, graph options for the horizontally. Then click to the OK. Now created for the box and whisker plot. The simple customized options only, the biomedical data in the MedCalc software. Double click the box plot, then open the new tab for the format for the fill the color and the border color change to the black. Then click to the OK, then change to the color, then thin or thickness, anyone you change it for the outlier. Okay, then detected for the outlier value in the hemoglobin 19.5 milligram per deciliters. So these are red color symbols mentioned in the box plot. So this is for the outlier detection in the critical data set for the biomedical data set. This is a simple data set, so I explained for the simple method. If you use a large data set, sometime the patient for the 1000 or 2000 patient, the detected for the high hemoglobin level, this is method used. And if you any doubt on this outlier detection method in the MedCalc for the biomedical data, leave me comments in the comment box. And if you like this video, click to the subscription button and support to me join to our channel membership. Okay, thank you for watching this video.